All right, so another clue that mass spec can give us is the fragmentation pattern. And we're not going to spend a lot of time on this. NMR, which we'll learn later on, is more useful. However, fragmentation patterns can be used when you have kind of two components. You're like, is it A or is it B type of thing? So we won't analyze the fragmentation patterns too much as they can get complex really easily. But basically, what you can think about is fragments of carbon chains breaking apart. So for example, if you had a methyl chain that would break off, you'd see a peak at something at minus 15 AMU or grams per mole from your molecular ion peak. If you had a methyl, if you had an ethyl, it'd be minus 29, right? That's the mass of an ethyl. Or if you had something maybe like a propyl, right? You just add another 14 to it. So let's see, that would be 43, right? And so we're not going to take a look at this too much, but it is kind of useful in if you have to decide between two complexes, right? So do you have this dimethyl cyclohexane, or do you have this ethyl cyclohexane, right? They both have 112 grams per mole. So if we take a look at our mass spec right here, that's our M plus peak. And so that's at 112. And so we can't tell with that information alone. What we can take a look at then is the peak after it, right? The base peak after it. And in this case, this one is weighing in at 83 grams per mole. And so if we take 112, subtract out 83, you'll get 29 grams per mole, which looks just like our ethyl, right? That's a fragment came off of this molecule that was an ethyl. And so if you take a look at these two compounds, one of them has an ethyl, the other one does not. And so it would make sense that if we have this ethyl cyclohexane, we could cleave the bond right here and then be left with our radical cation right there. And that's the mass of, that's that base peak that we're seeing. So you can see how it can be useful there, but we're not going to spend too much time on it. If you're curious, here's the dimethyl cyclohexane. Again, with its molecular ion peak at 112, and then a following peak right at 97, which corresponds to a change of 15, which is a methyl, right? So if you're deciding between two spectra, mass spec can be quite useful, but we're going to stick to other techniques more so.